All right, today's lesson is on exponent rules. This would be Unit 7, Lesson 1. All right, when you are multiplying variables like x's, we will actually add the exponents. So this means x times x times x 3 times. This means x times x times x times x 8 times. So by the time you think of the 8 times the 3, you end up adding exponents and you're going to get x to 11. So that's x to the 3 plus 8, which is x to the 11th. Final answer. All right, 2 to the 4th times 2 to the 2nd. You're supposed to write the same base. So that means that I actually have 4 2's, then I have 2 more 2's. That's a total of 2 to the 4 plus 2 power. It's a total of 2 to the 6th power. 2 to the 6th power turns out to be 64. Final answer. Let me caution you, a common mistake that happens is sometimes the students mistakenly want to multiply 2 times 2 and they want to get 4. And then they'll add exponents 4 plus 2 and they want to get 4 to the 6th. You cannot look at it that way. You can't multiply the 2 times the 2 because they're not free, so to speak, to be multiplied. If you think of your order of operations, you're always supposed to take care of the exponents before you multiply. So that's not just a regular 2, and that's not just a regular 2. Those are 2 to the 4th power and then 2 to the 2nd power. Let's see if we can make sure that we understand why. 2 times 2 is 4, times 2 is 8, times 2 is 16. This is 16. 2 times 2 is 4, 16 times 4 is 64. So it verifies that we do get 2 to the 6th or 64. If we take our calculator, we can confirm the result. And when we confirm the result, we see that we get 2 raised to the 4th power times 2 raised to the 2nd power is 64, or the same as 2 raised to the 6th power is 64. However, if I look at how we try to think of it as 4 times 6, or 4 to the 6th, 4 raised to the 6th power is a huge number. That answer turns out to be 4,096. No way, Jose. Please, please, please resist the urge to multiply the bases. You can't multiply unless they don't have an exponent other than a 1. Okay? So please resist that urge to multiply. Letter C, find your common x's, add exponents, find your y's, add exponents. X to the 2 plus 3, x to the 5th. Y does not have one showing, but we know it has a 1. You know there's one y there. Adding exponents, y to the 5th. X to the 5th, y to the 5th. Quotient rule. All right, quotient rule. This is when you have a fraction. This is when you're dividing. All right, so on the quotient rule, I'm going to take x to the 5th, which if you break it down is x times x times x times x 5 times. And this is x times x times x 2 times. 1x on the top will cancel out 2 on the bottom and leave me with 3 x's. The answer is x to the 3rd. You get that answer from subtracting. I can take the top exponent, subtract the bottom exponent, and I would get that same answer. So when you have a quotient, when you have a fraction, you can subtract exponents. I have more x's on top, 3 more, and so x stays on top. X to the 3rd over 1 or just x to the 3rd. Or x to the 5, subtract the 2, and that's where x to the 3rd comes from. X to the 3rd, final answer. I'm going to make sure I do the B just like I did before. Remember, that's like 5 3's. On the bottom is like 3 3's. Okay, 1, 2, 3 3's cancel. 2 3's are left, so it's 3 to the 2nd power, which is 9. Again, resist the idea that you would want to divide the 3's. You can't divide the 3's unless they don't have an exponent other than 1. So that would have been 3 to the 5 minus 3, which is 3 to the 2nd. Final answer, though, was B9. Since it's a number, we can confirm it with our calculators. We could have said 3 raised to the 5th power divided by 3 raised to the 3rd power is 9, which, of course, is 3 to the 2nd. All right, letter C. It's x to the 1st. So I'm going to say one of these x's cancels one of these and leaves me with 1. X to the 1st, or just x. 3 y's on the bottom cancel out 3 of these up here and leave me with 2 y to the 2nd. Subtracting exponents or canceling out top to bottom will help you see the answer. All right. Zero exponent rules. One of the easiest things, students generally like it. Anything raised to the zero power, except 0, is equal to 1. Y to the 0 is 1. 6 to the 0 is 1. Everything, look at the closest thing that the 0 touches. It touches the parentheses. It means everything in parentheses is going to go to a 1. So the answer equals 1. Power rule. Power rule. This is when you have an inside power raised to another power. So I have a 3 power already, and I'm going to raise it to a different power of 2. So I've got an inside exponent, and on the outside of parentheses, I got a second exponent. We're going to multiply those. So x to the 3 times 2 is going to equal x to the 6. Again, power to a power. The power rule says multiply the exponents. If you break it down to understand why you multiply, that's really x to the 3rd times x to the 3rd 2 times, and x to the 3rd times x to the 3rd 2 times. Now you can see we would add and get x to the 6. Final answer is x to the 6. 3 to the 2nd raised to the 4th power, or power to a power. Multiply the exponents, I get 3 to the 8th. 3 to the 8th turns out to be a very large number. 3 raised to the 8th power, 6561. We are going to try to change those numbers to regular numbers, like 3 to the 8th, 6561. All right, z to the 5 to the 2nd power, multiply your inside power times your outside power, z to the 10th. All right, expanded power rule. This is when we have parentheses. I've tried to say this several times. I think it's coming through to a lot of you. The outside exponent goes to the closest thing it touches, in this case is the parentheses. That means that the 3 actually goes with the 2 and it goes with the a both. So I'm going to multiply inside exponents times outside exponents, or that's 2 to the 1st, a to the 1st, 2 goes to the 3 exponent, a goes to the 3 exponent, 2 to the 3rd, a to the 3rd, 2 to the 3rd though is not my final answer. I can change that to 8, a to the 3rd. 3 times it's 2 times itself 3 times, 2 times 2, 4 times 2 again is 8. Letter B, again, same thing. It goes to the 6 and the x. 6 to the 1st power has to have part of the exponent 2, 6 to the 2nd. X already has 1 power, and I'm raising it to another power, so when you have a power to a power, you multiply and get 6. Shouldn't be your final answer, because you can do something more with 6 to the 2nd, which is 36. X to the 6th, that's your final answer. When you have a fraction inside parentheses, everything inside the fraction, because it's close, the first thing it touches is the parenthesis, it goes to the top and it goes to the bottom. So x to the 2nd has an inside power, raising it to an outside power. Multiply those, you get x to the 8th. X or y does not have an exponent showing, but we know it should be a 1. So of course 1 times 4, y to the 4th. Nothing else to simplify. Final answer. Letter D. We technically have 4 different parts. We got a 2 and an x, a 3 and a y squared. So there's 4 different things. Everything goes to the 3rd power. 2 gets raised to the 3rd power. X to the 3rd power. 3 to the 3rd power. And y to the 2nd to the 3rd power. You multiply a power times a power when it's like that, so I get y to the 6th. 2 to the 3rd needs to be changed to 8, x to the 3rd. 3 to the 3rd needs to be changed to 27, y to the 6th. Final answer has an 8 over 27. The next one talks about negative exponents, which we have been doing some lately. We saw in the last lesson, right before we took the last test, if you have a negative exponent on top, you're going to take it to the bottom, okay, and it becomes positive on the bottom. If you have a negative exponent on the bottom, you're going to move it to the top, and it becomes positive on the top. Now we have a situation here in our notes where we have parentheses around a fraction, x over y. If I happen to think ahead and I realize x is going to end up with a negative exponent, and the bottom part, y, is going to end up with a negative exponent, I'm basically going to move everything that used to be up here down and everything that used to be down here up. So I can actually flip that fraction inside, and that's where y over x comes from. But now the exponent has become positive. That's one way of handling a fraction to a negative exponent. All right, let's see if we can simplify these examples. First thing I need to do is move my x downstairs. If I do, I get 1 over x to the positive 3. Okay, 4 has a negative exponent. I'm going to move the 4 to the negative exponent down. It becomes a positive 2. I'm still not finished with this answer. 4 to the second should be worked out to 16. Final answer is 1/16. Letter C. There is no parentheses, so I just have to go across here and look. What is the exponent on the negative 4? Look closely. Does negative 4 have its own exponent? It doesn't. So since I don't see an exponent, I can always imagine that it has an exponent of 1. My goal here is to make sure that everything that has a negative exponent goes down to the bottom. Negative 4 is a negative number, but it doesn't have a negative exponent. X has a positive exponent, but y has a negative, so it needs to go down. My negative number 4 stays on top. X to the 5th stays on top. Y to the 2nd goes to the bottom. All right, letter D. Letter D says, I have a parenthesis, so I don't have to take care of that. Everything inside gets raised to the negative 3 power. Oops. But I can actually change my negative exponent to a positive exponent first, just like this rule right here shows. So let's do that first. I know that if I switch this, if I bring the y to the top, and if I bring the x to the bottom, x squared, then that becomes to the positive 3 power. Okay? Again, y came to the top, x to the second came to the bottom, and that became a positive 3 exponent. Now everything needs to get a piece of the 3 exponent, because the first thing that touches the 3 is the parentheses. It goes at the top and it goes at the bottom. So y gets a piece of the 3 exponent, and x to the second has a power raised to another power. Multiply, and you get x to the 6th. No more negative exponents, no more parentheses. Final answer. Letter E. Letter E, we want to do the mama rule. So when I do the mama rule, I'm going to multiply bigs. And notice I wrote my m's big. Multiply the big numbers. 3 times negative 2. Multiplying the big numbers gives me negative 6. Notice that I wrote the a's small. That's because I'm talking about exponents. The exponent on the x over on that side is a 1. So I'm going to add negative 2 plus 1, which is x to the negative 1. Now add y to the 1 plus y to the negative 3. That's y to the 1 plus negative 3 is negative 2. Everything that has a negative exponent needs to go to the bottom. It turns out, does negative 6 have a negative exponent? No. Negative 6 does not have an exponent up high, so we know it should be thought of as a 1. Okay, move the x downstairs, move the y downstairs. Your final answer would be negative 6 stays on top, still a negative number, just doesn't have a negative exponent. X to the first, y to the positive 2. Final answer. F. All right. Here we just have an A, B, C, and a D. Everything with a negative exponent we're going to change to positive. B does not have a negative exponent, so what I'm going to do on B is I'm going to leave B where it's at. So B to the third stays up here. A has negative, so A's are going to go down. What about C's and D's on the bottom? They're negative on the bottom, so where do they go? Up. D goes up. So if I rewrite, bring my A downstairs, A now has a positive 2 exponent. And upstairs, C has a positive 4 exponent, and D has a positive 1 exponent, which we do not have to show a 1. I did, but we don't have to. And I'll take the plus sign off because we know that's A to the positive 2. This is your final answer. Every letter is only listed once, and there's no negative exponents. All right. Now we're going to have a parenthesis. That means everything inside has to be raised to a negative 2. What's the exponent on the negative 2 to begin with? 1. This has an exponent of 2. This has an exponent of negative 4. So I'm going to have to make sure everything gets a piece of the negative 2. All 3 parts gets a piece of the negative 2 exponent. Now I'm going to write negative 2 in parentheses because I need to make sure I show that the negative sign was in the parentheses to begin with the negative 2. So it's negative 2 to a negative 2 power. X already had a 2, and we're going to take a negative 2, power to a power, multiply, negative 4. Y has a negative exponent already, times another negative exponent is going to make it positive 8. All right. Everything with a negative exponent needs to move. So this has to move. All right. X has to move. All right. If I move them downstairs, I'm still going to have negative 2 in parentheses. Now I have a positive 2 exponent. X has a positive 4 exponent, and those have been moved, and they're not on the top anymore. My final answer would be y to the 8th over. Now you have to consider for a second, that's a negative number. The negative was in parentheses because it was in parentheses to start with. Now it's going to be like squaring that negative number. What's negative 2 times negative 2? Positive 4. X to the positive 4. All right. Next, we have a small thing in regards to parentheses. I'll try to hammer and hammer and hammer this home. The parentheses goes to what it's directly next to. It's directly next to the parentheses, so that means it goes with the parentheses. The negative sign goes with the 3. So you basically have to use negative 3 times negative 3 twice. The answer is positive 9. Here, the closest thing that the 2 exponent is to is the 3. The negative sign is not necessarily going to go with the 3. So I'm going to take 3 times 3. 3 times 3 is 9. Then I'm going to come back and say, oh, okay, we got a negative sign. So this answer gives me a negative 9, but this answer with a 3 in parentheses, or negative 3 in parentheses, gives me positive 9. Your calculator can show you. If I say parentheses, negative 3, close them, squared, I get 9. But if I say negative 3 squared without parentheses, I get negative 9. It's all in how you interpret the answer. Here the negative stays with the 3. Here the negative does not stay with the 3. We simply do it last. You do the squaring, then you do the negative. All right, on the back of your assignment sheet, or on the back of the notes sheet, you see your classwork. We did this as classwork. This was intended to be something that you would start to practice the skills for exponent rules as soon as I went over the lesson in class. I tried to come around and help students. There seemed to be 2 or 3 that I helped a lot of students with. I'm going to go ahead and help you with the same 2 or 3. Please feel free to pause this video if you want, and then you can come back and check. I will show you the answers in just a second. All right, number 1, number 17, number 37. I'm going to work those out here so that you have the benefit of hearing me go through it. Most of the others are fairly straightforward. The answers will be posted actually on the next slide, so you can actually go back and pause the video, look at the answers. So take time to look at the back. Then you're going to have a separate sheet for homework. All right, number 1. The biggest thing students want us to do in number 1 is multiply the 3 and the 4. You can't. You can't multiply 3 times 4. You can't get 12. 3 does have a 1. You can't add the 1 in the 3 and get to 4. 12 to the 4th ain't even close. It's way, way, way too big. Here's what you got to do. For one thing, you have to make sure, before you multiply, you have to make sure you get rid of any exponents. So I need to do the exponents first. In class, we have posted the first 10 perfect cubes. 4 to the 3rd power turns out to be 64. So I can now, after I get rid of the exponent, now I can multiply 3 times 64. And the answer, I believe, turns out to be just 192. No x's, no y's, no variables, so that one turns out to be just a number. I want to do 17. 17. On 17, you have a choice. You can always use the exponent rules in whichever order you want. As long as you apply them properly, you should still get the same answer as someone else in the end who might have done it in the opposite order. I have x's, I have numbers inside that I can work with. I have x top, x bottom, y top, y bottom. Then I have an outside exponent. So I need to work inside to simplify and then work outside to get rid of my exponent in my parentheses. So I'm going to choose to work inside and see if I can simplify first. If I simplify first, the first thing I'm going to do is 4/16 reduces to 1/4. If you divide 4 by 1, you get 4 by 4, you get 1. 4 goes into 16 4 times. Then I have x to the 5th over x to the 1st. 1x on the bottom cancels one of those on top and leaves me with 4. X to the 4th is on top. There are 4 more x's on top. What about y's? Y to the 1st on top, y to the 4th on the bottom. This y cancels one of this y and leaves me with 3. There are 3 more y's on the bottom than the top. I still have my outside exponent of 3 that I've not done anything with yet. But just to pause for a second and take a look at what's inside. What's inside is a lot simpler, has a lot fewer items to work with after I simplify. Now, don't forget, everything inside has to get a piece of the outside exponent. So 1 gets a piece of the 3, 1 to the 3rd. X to the 4th gets a piece of the 3, inside power times outside power, multiply the exponents. 4 gets a piece of the 3, and y to the 3rd gets a piece of the 3, inside times outside, multiply exponents. Sorry, I forgot to put my 3 on my 4. I said it, but I didn't write it. All right, what is 1 times 1 times 1 3 times? Just 1. X to the 12th is already simple. What's 4 times 3? 4 to the 3rd power is 64, y to the 9th. This is the final answer for 17. You do not have to put the 1 on top. You do not have to do that. If you just say x to the 12th over 12, it is correct. It's understood to be a 1 there. All right, I would like to do 37. Okay. 37, I'm going to write it so that we're looking, well, I won't necessarily have to rewrite. I think we can work it where we are. I'm going to take the same approach with 37 that I just took with 17. I'm going to work on the inside first, since I got A's top bottom, B's top bottom, C's top bottom, and a negative 4 on the outside. I got 3 things to do this time. I'm going to work on the inside and simplify. Negative 7 over 3 can't be simplified, so I have to keep negative 7 and 3. A to the 2nd on top and A to the 3rd on the bottom. There are 1 extra A on the bottom, more A's on the bottom, and 1 extra. So 2 of these canceled out. 1 of those and leave 2 of those left me with 1. More B's on the bottom, and there's 1 more. C's. No C's. That really cancels to a 1, so all of your C's are on the denominator, and you still have an outside exponent of negative 4. To finish, I can actually now use that property about getting rid of the negative exponents. So I'm going to try to get rid of the negative exponents next. The property said that if you flip what was on the bottom and brings it to the top, and take what's on the top and bring it to the bottom, then you can change it to a positive exponent. So let's do that. So 3a, b, c to the 3rd over negative 7. I don't change anything. Those have 1 exponents, but it does become a positive 4 on the outside. All right, and the last thing, I'm going to get rid of my parentheses. Everything inside gets a piece of the 4. 3 to the 1st gets a piece of the 4, 3 to the 4th. A gets a piece of the 4 exponent, A to the 4th. B gets a piece of the 4th exponent, B to the 4th. C to the 3rd gets a piece of the 4th exponent, and I multiply to get 12. Negative 7, notice that I'm using parentheses to the 4th. The reason I'm using parentheses is the big parentheses, where was the negative sign? Inside the big parentheses. So I'm going to keep it inside my little parentheses. All it's left to do now is change your numbers. 3 to the 4th is 3 times 3 times 2, 4 times. I think that becomes 81. A to the 4th is positive. B to the 4th is positive. C to the 12th is a positive exponent. Negative 7 times negative 7 times negative 7 times negative 7 4 times. It's a big number. It's also a positive number because positive times, negative times negative is positive, times a third negative is negative, and then times negative again is positive. I think it's 2,401. Big number, but with calculators, it's not that much work. So your goal is to do these problems on the back. Do these as practice. Some of them are really short. For example, 7 is a 1. Anything to 0 power. 6. How many extra x's do you have on the bottom? I hope you see that you have 3. These 4 cancel 3 of these and leave me with 3. Or 4 of those cancel me with 3. X to the 3rd. Most of these are just really short and brief. Here I have x's. If you multiply x times x, you add exponents. So that'd be x to the 5, add negative 1, which would be x to the positive 4. So a lot of these are short. Some of these take longer. Do these first, and then do the homework, which will be taken for a grade.